You're sitting in the audience watching a brilliant presentation. The speaker is charismatic, the slides are gorgeous, and the logic is flawless. You find yourself nodding along to every word, completely satisfied. It all makes perfect sense. Then a few days pass. You sit down for an exam, or someone asks you to explain the concept, and your mind goes completely blank. You can't string together a single coherent explanation. We often blame our shrinking attention spans or the constant pull of social media for this. However, this failure is hardwired into our biology. Our brains simply aren't designed to retain information through passive agreement. To test how learning fails, physicist Louis Deslauriers ran an experiment at Harvard. He split a physics class into two distinct groups. Group A received the gold standard of teaching. A highly skilled professor delivered an entertaining, perfectly paced lecture where every concept was clearly explained. On their feedback forms, the students recorded having a great time and feeling highly confident in their grasp of the material. Group B was thrown to the wolves. They were given complex physics problems with very little guidance and forced to figure it out actively. They made constant errors and felt incredibly frustrated. Naturally, their course evaluations were terrible. Then came the actual exam. The students who struggled and hated the process scored twice as high as the ones who enjoyed the smooth lecture. Feeling confident in a classroom turns out to be a terrible predictor of actual knowledge retention. Psychologists call this the illusion of competence. It occurs when your brain mistakes the act of observing something for the act of acquiring it. When you watch an expert deliver a clear explanation, their thought process flows without any friction. Your brain mirrors that ease, tricking you into believing the speaker's fluency is now your own. You cannot learn to play the piano simply by watching a virtuoso perform. The biological process of building a new skill requires a completely different mechanism than passively taking in information. This project outline details the mechanics of learning, stating clearly in Russian, "Your brain is not a flash drive." We treat learning like a simple data transfer. But learning is a physical event. For a memory to stick, a physical synapse actually has to grow. When you sit through a standard lecture, the incoming audio and visuals hit the sensory cortex at the very back of your head. You are effectively loading raw inventory into a warehouse, but you haven't turned on the factory machinery to process it. Unless you force that electrical signal to travel forward into the rest of the brain, the data simply vanishes. The biochemistry of the brain dictates that passive information will evaporate in about 20 minutes. To build a permanent memory, you have to wake up that sensory cortex. Steven Spielberg understood this perfectly in Jaws by building the dread of the unseen shark long before delivering the reveal. In learning, you create that same hook by starting with a bizarre anomaly, an emotional spike, or an impossible problem, rather than a dry definition. The signal moves to the temporal lobe, connecting to old archives. Next, it travels to the prefrontal cortex, formulating a messy hypothesis. Finally, it reaches the motor cortex. The learner tests their hypothesis, and crucially, they fail. If you simply hand someone the correct formula right at the beginning of a lesson, you bypass this entire network. The brain stores the answer as foreign, disconnected data. Completing this biological circuit requires effort. Mistakes and frustration aren't side effects of a bad lesson. They are the physical prerequisites for building permanent neural pathways. The standard approach in classrooms and corporate training follows a familiar, comfortable script. Present the theory, show an example, and then assign practice. It feels logical, but biologically, it is entirely backward. The alternative is an approach known as productive failure, structured very much like a sandwich. You start by giving the learner an impossible task, the first layer of bread. They try to solve it, and they hit a wall. The theory finally arrives as a rescue mission. Because the brain has already experienced the frustration of being stuck, it prioritizes the information as the specific tool required to solve the puzzle. You finish with a second test, the final layer of bread. They apply the new theory, solve the problem correctly, and close the dopamine loop. Flipping the order of learning secures the information for the long term. We live in an environment where accurate facts are available instantly and for free. Delivering another passive monologue of information provides zero intrinsic value to anyone listening. True education requires designing deliberate, frustrating, and messy experiences that force the mind to struggle, because that struggle is the only thing that physically changes the brain.